All right, we're going to look at an example, and this is the State Union Bank problem on page 49 of your textbook, problem S1.36. And I'm going to read this problem to you. You can also follow along in your textbook, and then I'm going to give you a brief outline of what the decision tree looks like, and then I'll allow you to work on this, and I'll put the solution up on D2L. So here's the problem. The management of State Union Bank was concerned about the potential loss that might occur in the event of a physical catastrophe such as a power failure or a fire. The bank estimated that the loss from one of these incidents could be as much as $100 million, including losses due to interrupted service and customer relations. One project the bank is considering is the installation of an emergency power generator at its operations headquarters. The cost of the emergency generator is $900,000, and if it's installed, no losses from this type of incident will be incurred. However, if the generator is not installed, there's a 10% chance that a power outage will occur during the next year. If there is an outage, there's a 4.04 probability that the resulting losses will be very large, or approximately 90 million in lost earnings. Alternatively, it is estimated there's a 0.96 probability of only slight losses of around 2 million. Using decision tree analysis, determine whether the bank should install the new power generator. So here's a summary statement of the problem. The bank could purchase an emergency generator. And if that generator is installed, there's no losses. But if it's not installed, there could be a power outage. And if there is an outage, there's a 4% chance of large losses. Otherwise, there's only small losses. So what's the decision? Probably one of the most difficult things about this process is determining what the decision is. So I want to let you think about that just for a little bit, but there is an initial decision, and that decision is going to be represented by a square. So what do you think that decision is? Does it have to do with power outages? Does it have to do with the losses, whatever's going to happen with the losses? Well, the original decision is there's two choices that the bank can make. And I'm going to abbreviate this. It can either purchase the generator or not purchase. And if they purchase the generator, what does that cost? There's going to be a cost of 900,000, and I'm going to abbreviate this and put that's 900,000. And if they purchase the generator for 900,000, there are no losses. So the return, or the cost, if you will, is $0 if the generator is purchased. And then that's all that happens. No matter whether there's a power outage or not, because the generator is purchased, and there'll be no loss, but there will be a cost of 900,000. So now we have to think through what's going to happen if the generator is not purchased. And not purchased, not PG, not purchase that generator. What's the next thing that happens? Well, hopefully you can see that there's a random event. And the first random event that would occur would either be there would be a power outage, or no power outage, no PO. And so if there is a power outage, what's the next thing to occur? Well, there's going to be losses because we don't have a generator. So there will be large losses, or there will be small losses. And so if there's large losses, there's going to be a return. Excuse me, there'll be lose $90 million, or 9,000 thousands. And if there's small losses, that's going to be a negative. And if there's small losses, you're going to lose 2 million or 2,000 thousand. And then if there's no power outage, if there's no power outage, but you don't have a generator, there's not going to be any loss. So now the question that completes our decision tree. And so now your question is that and I'm going to leave for you to solve, is how do you calculate, and let's call this location 2 and location 3. How are you going to calculate the expected value at location 3 and the expected value at location 2? And then what will you decide to do here at the decision? So at this point, I'm going to leave this problem to you. You should be able to work through it and solve it and calculate these expected values and calculate the expected value for this overall decision and help State Union Bank decide what to do. I'll put the solution up on D2L. I want you to work through it and try it, but to then come back and look at the solution. All right, good luck.